Welcome to Math Superville. We're going to discuss how to find the inverse of a 2 by 2 matrix. The inverse of a 2 by 2 matrix. A 2 by 2 matrix is denoted by matrix A, which consists of the elements A, B, C, and D. They're all enclosed in opening and closing brackets, where A, B, C, and D are real numbers. The determinant of this matrix was discussed in another video. So the determinant of A is, we denoted it with the notation det A, and this is equal to, you put the elements within two vertical bars. So this is the notation for the intent to find the determinant, and then next is to multiply out the elements in the leading diagonal, which are A and D. So you multiply those two elements, you get AD, and subtract out the elements, the product of the elements on the other diagonal is BC. So we already know how to find the determinant of this matrix. So to find the inverse of matrix A is found as follows. Step 1, find the determinant, which we already know. Which is AD, the product of A and D, minus the product of B and C. Step 2 is to find what you call the matrix A superscript star. And this matrix consists of writing the elements of matrix A, but reorienting them or switching their order in a particular manner. What do? We switch the position of A and D, and then negate or change the signs of the others. So once we have this, we go to step 3. And in step 3, we find the inverse. The inverse of matrix A is denoted as A with a superscript of a negative. Don't confuse this with the reciprocal of A. So this is the notation for the inverse of matrix A. And this is equal to the product of the reciprocal of the determinant. So that's 1 divided by det A times matrix A star. And that gives us the inverse. To check, whether A inverse and A are inverses, or that you have come up with a true inverse, you just multiply. So you must have, as working knowledge, the ability to multiply matrices. So check that A inverse times A should be equal to the identity matrix. So, or this should also be A times A inverse. And we should get the identity matrix. The identity matrix is the matrix consisting of ones on the leading diagonal and zeros everywhere else. And that is the process of finding the inverse of a 2 by 2 matrix. So let's look at an example. Find the inverse of matrix A, which consists of the elements 1, 2, 3, and 4. So step number 1, find the determinant. So we find the determinant of matrix A, and this consists of writing the elements within 2 vertical bars, and then showing that you're going to multiply the elements on the leading diagonal and subtracting out the product of the elements on the other diagonal. So to yield 1 times 4 minus 3 times 2. So that gives us 4 minus 6, which is negative 2. In step 2, we find the matrix A star. The matrix A star gives us, so we have elements 1 and 4 switching places and then changing the signs on the others. And then in step 3, we find our inverse. So the inverse of matrix A is denoted as A with a superscript of a negative 1, and this is equal to 1 divided by the determinant of A times matrix A star. And so this gives us 1 divided by negative 2 times the matrix consisting of the elements 4, negative 2, negative 3, and 1. And this gives us the A inverse, which is the inverse of the matrix we are given to be. So you multiply the reciprocal of the determinant by each element in the A star matrix. So you get 4 divided by negative 2, and then negative 2 divided by negative 2, negative 3 divided by negative 2, and then 1 divided by negative 2. This gives us negative 2, 1, 3/2, and negative 1/2. In the last step, what do? We check. So we want to check that we have the correct inverse. So we will multiply matrix A by A inverse. What should we get? We should get the identity matrix. So let me change the color so at least you can see what we will do as we proceed. So we have 1, 2, and 3, and 4. And we are multiplying by A inverse. In the language of linear algebra, the matrices that you multiply must meet certain conditions. And the condition is that the number of columns of the first matrix must match the number of rows of the second matrix. In addition, we should also point out that the determinant of the matrix that we are given should not be 0. Because if the determinant is 0, then you will end up dividing by 0 at some point. And that is when you're finding the inverse. And if you divide by 0, of course, you know, you will end up with some undefined result. And in that case, we will classify matrix A as singular, or another way to say it, it is non-invertible. So we just multiply row by column to give us the first element of our result. And then again, row by column to get the second element. And then we go to the second row by this first column to get the third element. And then the second row by the second column to get the last element. So we will get this to be 1 times -2 plus 2 times times 3 halves. So we are done with the first row and the first column. The second one is 1 times 1 plus 2 times -1/2. That gives us the second element. So we go to the second row, first column. So 3 times -2 plus 4 times 3 halves. And then we go to second row, last column. So we end up with 3 times 1 plus 4 times -1/2. And if you just notice, the first one gives us -2 plus 3. The second one gives us 1 minus 1. The third one gives us -6 plus 6. The last one gives us 3 minus 2. And as you can see, our result is the identity matrix, which is 1, 0, 0, and 1. That is what we expected. We expected that the product of A and A inverse should be the identity matrix. This is normally denoted as I. And so we are able to notice that we have seen the process of finding the inverse of a 2 by 2 matrix and how we can check. So the last step is to check whether the inverse found is in fact the correct inverse. So until next time, we will stop there. We will continue with the process of applying these concepts in solving a system of linear equations, primarily 2 by 2, consisting of 2 by 2 matrices and 2 by 1 matrices. So we'll see that in our next presentation. Thank you.